In this lesson, we are going to introduce L'Hopital's rule. This is kind of a nice shortcut, but it's going to take us back to limits. And when we were doing a limit, we were had some sort of a function, and we were trying to find the limit. And our kind of go-to was we were going to plug the value in and see what we get. And if you remember, we're always kind of about what we were approaching on either side. Right? It didn't matter whether we got there or not, but what were we approaching on each side? And so we came across some problems such as this, where when you plug in a value, if you plug in 1 into this, you got 1 plus 1 minus 2. So that's a 0. And then you got a 1 minus 1 is a 0. So that forced us to do some different things. We had to factor the top, see what we had. This kind of implied that we had a hole. So the limit existed, but we needed to figure out what it was. So this, L'Hopital's rule, is kind of a nice shortcut that we can do. So when we have that kind of a situation, we have a 0 over 0, or a 1 over 0, or an infinity over infinity, or if you don't even have a fraction and you just have something, a 0 times infinity, so something is getting infinitely small, something's getting infinitely large, who's winning that battle? And then you have something like an infinity minus an infinity. It's not necessarily 0, because one infinity might be larger than another infinity. So you have some things to consider when you have these types of situations. Well, L'Hopital's rule is if we find we're in one of these situations, we're just going to do the derivative of the top, derivative of the bottom, and then just essentially start over. And we're going to end up getting the exact same thing. So I'm going to show that on this first example of here's how we would have done it before. And then we'll do the new method and kind of show, see what you think and see if it's a little bit more efficient. So if we have this, we would have factored the top, right? So here's how we would have done it the old way. But I still have to start off knowing, do I have this scenario that I can use this method? Like, do I have a 0 over 0, 1 over 0? So if I plug in 1, I do have a 0 over 0. So we're going to factor the top. And so let me kind of start to work through that. I'm going to factor out an x, which is going to give me an x squared plus an x minus a 2. So then that means I have the limit as x approaches 1. If I factor that, I get an x. And we'll multiply this to negative 2, that adds to 1. I get a plus 2 and the minus 1 over that x minus 1. And if you remember that the reason we had a 0 over 0 is because we had a common factor. That's what gives you your 0, and that's what gives you your 0. And so we canceled them out, and then we did the limit now as x approaches 1 for this, which is just going to be x times x plus 1, or x plus 2. And then now we're ready to plug it in. So now we plug it in, we get a 1 times a 1 plus 2, and we're getting 1 times 3, which is 3. So our limit is 3. Okay, so we're approaching. So if you were to graph that, you would have a hole here. You might not see it on your calculator, but you would be approaching the value of 3. So the new way is recognizing that we can do L'Hopital's rule. So we're going to still know that we had a 0 over 0, but we can do the derivative of the first, or derivative of the top. So the limit as x approaches 1. We do the derivative of the top, which is 3x squared plus 2x minus 2 over 1. Now we have no chance of getting a 0 over 0. Now be careful with this. Don't keep on doing the derivative over and over and over and over again, because actually you can do this. If you still have a 0 over 0, you can do it again and then again. But don't go too far. You want to get to a point where you don't have a 0 over 0 anymore. So do it the first time, test it. So let's plug in our 1. So if we plug in our 1, we have 3. And I know that I'm not going to get a 0 on the bottom. So I know I'm good. So I'm just going to go ahead and figure out the value. So plus 2 times 1 minus 2 divided by 1. So we're looking at a 3 plus a 2 minus a 2 over 1, which is still going to get us a 3. All right, but I think that's a little bit of a nicer, more efficient way of doing that, especially when you had something like this where you had to multiply by a conjugate and things kind of got a little bit messy. We're going to have a different way of doing that. So, but that's the idea of L'Hopital's rule. Don't go too far on doing the derivative because you can do this more than once. But once you get to a point where you don't have a 0/0 or one of these scenarios, then stop, go ahead and plug it in and figure out what your limit's going to be.